This video is on correlation. Correlation is how closely two variables are related. So we're trying to talk about how are the data points related to each other. So correlation is how closely two variables are related. We can really see this when we're looking at scatter plots. So it can be shown on a scatter plot. There are two types of correlation we can have. It's based on strength and direction. So strength tells us how closely things are related. So if it's really related, the two variables are really related to each other, and one causes the other, then the correlation would be strong, versus if the variables don't really rely on each other, the correlation would be weak. We can also have the direction of the correlation. It would have a positive correlation or a negative correlation. And of course, if the variables don't relate to each other at all, there would be no correlation because there would be no relationship between the two variables. So first, let's talk about positive correlation. Positive correlation is as one variable increases, the other also increases. So as the x variable increases, so will the y variable. So if we're thinking about positive with linear correlation, this would be positive slope. An example of this, the amount of time spent exercising. So if we spend time exercising, that would be increasing. What else would also increase? Maybe the amount of calorie burned. So the number of calories burned would be positive correlation because as one increases, so does the other. So if we were to look at this as on a scatter plot, we would have our time is increasing, so our calories would want to increase as well, the amount of calories burned. So we would have it looking more like this. We could see that as time increases, the amount of calories burned will also increase. And what I've shown here is that our data points are really grouped together fairly well. So this is what would be considered a strong correlation because I've grouped them together fairly closely. This is a positive correlation because our data points are going as the x's increase, so are the y's. So I've shown both a strong correlation, but I've also shown the positive correlation. Next, we'll talk about negative correlation. Negative correlation states that as one variable increases, the other decreases. So as the x's increase, the y variable will decrease. So an example of this, again, amount of time spent exercising. So as we increase our time exercising, something that will decrease might be weight. So these two have a negative correlation, not because it's bad, but because as we increase our time, then our weight would hopefully decrease. So to show this on a scatter plot, I'm going to show a negative correlation, but I'm also going to show a weak correlation at the same time to show you what the difference between strong and weak is. Negative does not automatically mean it's going to be a weak correlation. I'm just showing the differences between them. So a weak correlation is where we're going to make it go negative. A weak correlation is when the data points are not as strongly grouped together, but you can still see the negative pattern here. They're not as closely grouped together, but they are going in a negative fashion. So as the x's increase, our y's are going down. So this would be considered, in this case, a weak, but it is a negative correlation. And again, negative correlation does not mean it's bad. It just means that as one increases, the other decreases. And last on this is we have a no correlation. This is when there is no linear pattern or relationship between them. So an example of this, again, amount of time spent exercising and maybe your hair length, because these have nothing to do with each other. So if we were to look at this in a scatter plot, our data points would be completely irrelevant to each other. They would not match up, they would not create a pattern. So our data points would just be kind of all over the place. There would be no pattern whatsoever to them. So that doesn't make a line, it doesn't really make anything. This is a no correlation, because they have nothing to do with each other. Now, another way we can see this is by looking at the correlation coefficient. The correlation coefficient is the letter R when we use technology to find our regression equation. We will also at the same time get the correlation coefficient. Do not be confused by the word coefficient here. It is not a number being multiplied to a letter. The coefficient here is talking about that it is the correlation coefficient. They go together into one phrase. The correlation coefficient is a number, but it is between two specific values. So a number between -1 and +1. And this correlation coefficient actually tells us how strong it is. So that tells how strong the correlation is. So we might see a pattern on here, and we might think that it's pretty strong, but it could be rather weak. You can still see a linear pattern in this graph, but it might be fairly weak compared to this pattern right here. The correlation coefficient will actually tell us how strong the correlation is. So we'll have it from -1 to +1. Now, from the closer it gets to 1 or -1, it actually becomes stronger. And actually, if it's on the -1 or 1, that tells us that it is a perfectly linear data set. So if it's closer to 1 or -1, the stronger the correlation. Now the negative tells us it's going to be a negative correlation. The positive tells us it's a positive correlation. So as it gets closer to the ones, either of the ones, that becomes a stronger relationship between them. And again, if it actually is one of the ones, then that means that the data points are a perfect linear pattern. So if the values get closer to 0, which is directly in the middle of -1 and 1, that actually means that the weaker the correlation becomes. So that's where we get the weaker value. The weaker the correlation. So if we have a number line here, I would have my -1 and my +1. I have my 0 in the middle, but I might have values somewhere in between. So I might have that -1/2 and maybe a +1/2. So if we're talking about these, we know that at -1, this is going to be a perfect, so perfectly linear. This will be a perfect negative correlation. Same on the positive. This will be a perfect, because it would be perfectly linear, but it would be a positive correlation. And so at the 0, this would mean that it would have no correlation. As they move away from 0, the stronger they become. So if they're in the halfway mark, they're not going to be perfectly strong, not going to be perfectly weak. You will see some discrepancies in the data points where they're not going to be in a perfect line, but they will be more linear in pattern. So if we look at this, the perfectly positive one would be all of the data points would be going in a positive manner, but perfectly linear, meaning I could draw a line through these data points and I would not have to move it up or down. It would be straight. The same would hold true for the negative correlation, just that it would go in a negative slope, but it would again be perfectly linear, meaning I could draw a line through all of these data points and it would be straight. So with the no correlation, our data points would be completely scattered. There would be no relationship between them. There's no linear fashion, no line or picture that we could draw from this. These are all completely scattered and they mean nothing to each other. So if we wanted the negative half, it would still go in the negative fashion, but the points would be scattered away from each other, but you could still see a shape of a general line. Same would hold true for the positive half. They would go in a positive fashion, but they would not be perfectly linear, but you can see a general form of a line. So the ones, -1 and +1, would mean that we had a perfectly linear data set. 0 would mean that we have no correlation whatsoever. And then as it gets away from 0, the stronger they become.